Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 2.4, Problem 6. This is Section 2.4, Problem 6. It says multiply the matrices. And now this time you're given three matrices to multiply, and there are some parentheses. So as with any type of math, you need to do the work in parentheses first. So the two matrices in parentheses you have to focus on first. You can ignore anything outside of the parentheses until you do the work in the parentheses. So within the parentheses, we have two matrices to multiply. The first one has 2, 1 in the top row, -3, -6 in the middle row, 4, 0 in the bottom. And we want to multiply that times the matrix 1, -2 in the top row, 2, -1 in the bottom row. And then there's times another matrix outside the parentheses that we'll get to later, but for now I'm just focused on what's in the parentheses. So first of all, is there a solution for that? Can we even find an answer? So what we want to do is see if the number of columns in the first matrix is equal to the number of rows in the second matrix. And again, the way to do that is write the dimensions of each matrix underneath. The first matrix is a 3 by 2 because it has 3 rows and 2 columns. And the second matrix is a 2 by 2 matrix. It has 2 rows and 2 columns. And when you look at the inner numbers, they do match. They're both 2. So there is an answer. And that answer will have the dimensions 3 by 2, the outer numbers from when you write the dimensions under each matrix. So I know there's an answer to find, and I know what it's going to look like. So let me write some of that underneath, and then I'm going to go off to the side and multiply that times the matrix that's outside of the parentheses. Again, I'm just working in the parentheses right now. So 3 by 2, I'm going to have a matrix with 3 rows and 2 columns. And I'm going to set up 6 boxes in the shape of my matrix to write the work in so you can see where it's all coming from. So what we need to do, as with any matrix multiplication, is multiply systematically every row of the first matrix times every column of the second matrix and put the answers in the blocks where they go. So I'm going to start by multiplying the top row of the first matrix, 2, 1, times the first column of the second matrix, 1, 2. So first times first is 2 times 1, plus second times second would be 1 times 2. Oops. Let me neaten that up a little bit. Second times second is 1 times 2. So first times first, 2 times 1 is 2. Second times second, 1 times 2 is 2 again. 2 plus 2 is 4. So, and again, where did I put that answer? I multiplied the top row of the first matrix times the first column of the second matrix, got the solution, put it in the top row and first column of the matrix. It's the solution. So next I will multiply the top row of the first matrix, 2, 1, times the second column of the second matrix, -2, -1. So now first times first is 2 times -2. Plus second times second is 1 times -1. And now 2 times -2 would be -4 from the first times first. And the second times second, 1 times -1 is -1. So -4 plus -1 would be -5. And notice where that -5 goes. I multiply the top row of the first matrix times the second column of the second matrix, and I put the answer I got in the top row and second column of my answer. So next I'm going to multiply the middle row of the first matrix times the first column of the second matrix. So the middle row of the first matrix is -3, -6 times the first column of the second matrix is 1, 2. So first times first is -3 times 1. And then second times second is -6 times 2. So first times first, -3 times 1 is -3. And then second times second, -6 times 2 is -12. 12. And when you add those -3 plus -12, you get -15. And again, I multiplied the middle row of the first matrix times the second column of the second matrix, and the solution I got went in the middle row and second column of the solution. Now I'm going to multiply the middle row of the first matrix, -3, -6, times the second column of the second matrix, -2, -1. So first times first is -3 times -2 plus second times second, -6 times -1. So first times first, -3 times -2 is +6. And then second times second, -6 times -1 is +6 again. So +6 plus another +6 is +12. And again, what I did is I multiplied the middle row of the first matrix times the second column of the second matrix, and the solution I got went in the middle row and second column of the solution. So now finally across the bottom, I'm going to multiply the bottom row of the first matrix for 0 times the first column of the second matrix, 1, 2. And when I do that, first times first, 4 times 1, plus second times second will be 0 times 2. And now when you multiply first times first, 4 times 1 is 4, and second times second, 0 times 2 is 0, and when you add 4 plus 0, you get 4. And I put that answer in that spot because I multiplied the bottom row of the first matrix times the first column of the second matrix, and my answer went in the bottom row and first column of my solution. And one more box to fill in to finish the work in parentheses anyway. I'm going to multiply the bottom row of the first matrix for 0 times the second column of the second matrix, -2, -1. So first times first will be 4 times -2. Plus second times second will be 0 times -1. So the first times first, 4 times -2 will be -8. Plus the second times second, 0 times -1 will be 0. And when we add -8 plus 0, we get -8. And again, the answer went in that spot because I multiplied the bottom row of the first matrix times the second column of the second matrix, and the answer I got went in the bottom row and first column of my solution. So now that's the answer. Again, it's written with all those boxes. That's the work in parentheses. And I'm going to have to multiply that times the matrix outside of the parentheses, which has a 3 on the top by itself and a 1 underneath by itself. So this problem has become the work I got here from the parentheses, which is 4, 5 in the top row, and then -15, 12 in the middle row, and 4, -8 in the bottom row. And I want to multiply that times the matrix that was outside of the parentheses, which is a 3 in the top and then a 1 underneath. So it's just that one column. So first of all, does this multiplication even have a solution? Is the number of columns in the second matrix equal to the number of rows in the first matrix? So again, the way to check that is write the dimensions underneath each matrix and then see if the inner numbers match. So this first matrix is a 3 by 2. It has 3 rows and 2 columns, so it's a 3 by 2. And now the second matrix is a 2 by 1. It has 2 rows and 1 column. So now, do the inner numbers match? Yes, indeed they do. The inner numbers for each one is a 2. So there is a solution, and not only do I know there's a solution, the solution will have this shape, a 3 by 1. The solution will have 3 rows and 1 column. So now, what we're going to do, let me write out those boxes and we'll start filling them in. I'll write it off to the side here a little bit. We're going to have a matrix that will have 3 rows and 1 column. So my solution will be this shape here. put brackets on it. So now what I need to do is systematically multiply each row of the first matrix times the column in the second matrix. So to start that off, I'm going to multiply the top row of the first matrix, 4, 5, times the only column in the second matrix, 3, 1. So when I do that, first times first will be 4 times 3. Plus second times second will be 5 times 1. So first times first, 4 times 3 is 12. Second times second, 5 times 1 is 5. And then when you add 12 plus 5, you get 17. And I multiply the top row times the only one column there is. So my answer went in the top row and the only one column there is. So now the next one down, I'm going to multiply the middle row of my first matrix, negative 15, positive 12, times the only column of the second matrix, 3, 1. So first times first will be negative 15 times 3. Plus second times second will be 12 times 1. And when you multiply those values out, the first times the first, negative 15 times 3 is negative 45. And then second times second, 12 times 1 is 12. And now when you add those values, negative 45 plus 12, you will get negative 33. And again, that result goes in that spot because I multiplied the middle row of the first matrix times the only column of the second matrix. So the answer goes in the middle row and the only column of the second matrix. That's why we put it there. And finally, one more box to fill in. I'm going to multiply the bottom row of the first matrix, 4, negative 8, times the only column of the second matrix, 3, 1. So first times first is 4 times 3, plus second times second would be negative 8 times 1. And first times first, 4 times 3 is 12, plus negative 8 times 1 is negative 8. 12 plus negative 8, or 12 minus 8, will give me an answer of 4. And again, I put the 4 in that spot of the bottom row in the only column because I multiplied the bottom row of the first matrix times the only column of the second matrix, and that answer went in the bottom row, only column. So now that is the answer, but again, it's probably best not to show it with all that work. So I can write it right here. I have some room. The answer is, the final answer after all the work is a matrix with only one column, and it has a 17 in the top position, negative 33 in the middle position, and a 4 in the bottom position. And that's the final answer after all that work. Again, we did the work in parentheses first, got an answer, and then did the answer we got times the matrix outside of the parentheses. And when we did all of that, we wound up with this one simple matrix, 17 on top, negative 33 in the middle, and 4 on the bottom.